The next question is Jun2005 question 4. Figure 4.1 shows a metal sphere at rest, there it is there, at the surface of a deep tank of water. The sphere is then released. Figure 4.2 shows it moving down through the water at an instant when its speed is v. The forces experienced by the sphere are its weight, which acts downwards, an upthrust u from the water around it acting upwards, and a frictional force r because of its motion through the water acting upwards. Forces w and u are constant, but r is proportional to the speed v of the sphere in the water. Okay, so r is going to increase the quicker that the metal sphere is moving. Use this information to deduce an expression for the magnitude f of the resultant downward force acting on the sphere at any instant. Give your answer in terms of w, u and r. So we're going to draw these in on this. You've got w acting down the way. I'll draw the two in a different colour. And you've got two forces acting up. You've upthrust and you have that resistive force r. So those two forces are acting up, w is acting down, and therefore the resultant force is going to be w take away the other two because it is definitely moving downwards. So F is equal to w minus u plus r. Or you could write w minus u minus r. On the axis of figure 4.3, sketch a graph to show how the magnitude F of the resultant downward force depends on the speed v of the sphere. Label a point on the F axis with a relevant value. Right, so you have to sketch a graph to show how the magnitude of the resultant downwards force depends on the speed v of the sphere. Now, you know that F is equal to w minus u plus r, but r is constantly increasing. And eventually r will get to a value where u plus r is going to cancel out the effect of the weight, and therefore F is going to be equal to 0. So F is going to end up down at 0. It's going to start off at a value where the resultant force W is equal to W minus U because there'll be no R force there. So initially when the ball goes into the water, it's going to experience W down, but there'll always be this U force acting upwards the minute it hits water, but there won't always be this R force. You know that F is directly proportional to R, F is directly proportional to R. Sorry, R is directly proportional to V, and therefore as V increases, R decreases accordingly. So as V doubles, R halves, and therefore it's going to be a straight line which goes down the way, because that resultant force is going to decrease, decrease, decrease until these are equal and you have terminal velocity of the sphere. And so this value here that needs labelled is going to be where there's no R in the equation initially, in other words W minus U. You could also say down here V equals terminal velocity. You can't see that. Okay, now the next bit of the question is really quite a horrible bit of a question. It shows you a diagram. It says this figure shows how the speed v of the sphere depends on the time t after release at the surface. Write a description of the motion of the sphere through the water, deducing information from figure 4.4, which is this, and the introduction to the question. Use appropriate words such as speed and acceleration. So there's obviously going to be marks for those two things there. Refer in times to the motions at time t equals 0, just after t equals 0, and after t equals t1. There's no reason why you couldn't go through that and underline those the way I have. So we're going to write 3 sections in this to try. There's 5 marks available and 1 for your quality of written communication. And so what we're going to do is we're going to write 3 wee bits here down the side. To make sure we don't leave anything out. T equals 0, further down, t equals t1, and further down. Sorry, this one here is just after. Just after t equals t0. And then the last one then is t is equal to t1. Right, so what is happening? So up to t1, initial value of the speed is 0. So initial speed. Now, I am writing this in shorthand. Unfortunately, you have to write it in sentences because they're looking for complete sentences for the quality of written communication. It still doesn't do any harm to make yourself 3 wee headings there. T equals not, just after T equals not, and T equals T1. And then write these bits here in proper sentences. So the initial speed is 0, or it's at rest. And then what happens to it? Well, obviously its velocity increases, but not uniformly. So its weight is causing it to gain speed. Accelerate, but it's not uniform. And then the last part we're going to write then is that the acceleration at t equals naught is less than that of g, because you always have this upthrust which is acting. If I draw this again, you've got r and u at the beginning. You've no r at the very beginning. But if you have g acting in that, I should write mg there, because it's a force, then that it'll never accelerate with acceleration due to gravity due to the upthrust of the water. So there's 3 marks, 1, 2, 3. Then just after t equals naught, then the acceleration starts to decrease. And we know that from the graph because the acceleration is non-uniform. And this means that it's actually, this is a retardation. In other words, it's starting to, even though it's moving faster, it's not getting faster at the same rate. And therefore acceleration decreases and eventually ends up at 0 at t1. And then the last part then, from t1 onwards, the speed is constant. And I would write in there, the sphere has reached its terminal velocity. Now the problem with that is there's 5 marks there and it's really difficult to see where to go. That's what I would advise you to do when you see a question like that. Make sure you're including everything in the question. You may not get every single point they're looking for, but at least you'll be near enough there. So make sure you do that.